So let's look at our composition book. Let me open this up. We have finished in our Teach Tracker. You want to go ahead and highlight reporting category 5. We have finished all of this. Yay! So all of reporting category 5 dealing with exponential functions. We've done all of that. Okay, we've also done on reporting category 1, 11B, which was the laws of exponents. So we've also done that. So I'm going to check off reporting category 5. So your next EOC review will be reporting category 5. Then we are doing, this is our unit 9, all of this, unit 9. It's about the quadratic function, so you're going to learn all about that the next 2 weeks. And then the last week before EOC, we'll finish out reporting category 1. So basically we have 2 units. Because of time, we are not having an actual test because that takes a review and a test day. 2 days we don't have. So on your Teach Tracker, we're not doing a test. That would be unit 8. But what we are doing is that EOC review. And since I needed a test grade in the grade book, we're going to count that as a test. Take home test. There you go. You can use your resources as long as you show your work. Because we don't have time. All right, so let's look at unit 9. Quadratic functions. So here are the skills for it. So you probably never heard of a quadratic function. So we are going to learn all about that. On the back, we have some vocabulary. So quadratic function, a function in which the greatest power of the variable is 2. Parent function of quadratic is y equals x squared. Parabola is the shape of a graph of quadratic. Vertex is the point where the parabola changes direction, h of k, also called the maximum or minimum point. Axis of symmetry, a vertical line that divides a parabola into 2 congruent halves. Maximum, minimum, the y-coordinate of the vertex, so it's how high or how low the graph goes. Zeros, anytime you're asked for the 0, that always means your x-intercept. Solution to the function, the x value of the x-intercept. X-intercept, point where the function crosses the x-axis. Domain, all possible x's. Range, all possible y's. So it's a lot of the same stuff that we have done with linear functions, dealing with 0, solutions, x-intercept, domain, range. Now we're just applying that to quadratics. Another one is also called roots. Is also x-intercept. I don't know why, but x-intercept has a lot of names. I don't know why, but if you see that, that is what it means. So I want you to go to your calculator and let's just graph the parent function of quadratic. So what it was is x squared. So go to y equals, put in x squared. Hit graph. This is unlike anything you've graphed before. The shape is called parabola. Where do you think the vertex would be? If you look at the definition, you look at our graph. 0, 0 is your vertex. Yep. Axis of symmetry, that's the line that cuts it into 2 equal halves. Where would that be? The y-intercept, exactly. This cuts it directly in half. Makes it where it's the same on both sides.
Would the vertex always be 0, 0?
No. Mm-mm. So let's see if we add, let's say I add 5 to it. What do you think that's going to do to it? What does it do to our linear function? That would be your y-intercept. Yeah, it moves it up. So if we graph it, it just translated it up 5 units. Does this one have an x-intercept? Nope. And that's okay. You don't always have to have an x-intercept. It's because it changes direction and it's above the origin. It's never crossing that x-axis. We can also, I'm going to clear this out. I'm going to flip it around. So remember with linear, y equals x was like our linear parent function straight line through the origin. And then to flip it around, we made it a negative x. So same thing with quadratics. I'm going to do a negative x squared. What do you think that's going to do to our function?
Negative.
Yeah, instead of it being like this, it's going to go like this. It's going to go down. So I'm going to hit graph. It flips it over. Looks like a roller coaster now. I guess the other one could have been a roller coaster, but this is really like going up the hill, going down the hill. Okay, so let's look at our new digital interactive notebook. It's right here, Unit 9, DIMB. I've got to find mine. Okay, so here is our new digital interactive notebook, Unit 9, Properties of Quadratics. Same things on the first slides. So we're going to go to slide 5. Smaller. And we are going to, I think, drag. Yeah, there we go. Look to your left and we can drag. All right, so based on what I've given you, what we've talked about, let's go ahead and label the items. We know where the vertex is, right? On this one, it's here. That's what, 3, -4? So go ahead and drag that over. Axis of symmetry. We're going to have to do a little rotation here and move it right here. Drag and drop, guys. And then zeros is our x-intercepts. So we actually have 2 on this one. Y-intercept is where it crosses the y-axis. Did y'all see how I turned the axis of symmetry? See this little pivot point right here? You can turn it using that pivot point. Y-intercept, where it crosses the y-axis. Looks like it's at 1, 2, 3, 4, 5. So 0, 5. Let's see. Solutions is also where we have zeros. Roots is also x-intercepts. X-intercept is also there too. Goodness, we have a lot. I think I'm going to put it right there. Where else will I put, or where let's see, vertex is at that bottom point right there, which is also known as our min and our max. We have one more spot. What's going to go here? What do we not use? Parabola. Parabola. No, it's parabola though. Okay, so we have it labeled on our diagram. What else do we need to do? We need to identify our domain. What's our domain here? Domain is all possible x values. So what are the x values on here? What can you tell? Do what? No, the x values. What can the x values be on this graph right here? All real numbers. Or negative infinity, positive infinity. Okay, and then what about range? Range is what values? Our y values. What can the y values be? -4 to infinity? How else could we write that? Y is greater than or equal to. How do we do that symbol? Insert.
You just underline.
Yeah, we could underline it. Greater than, equal to. Is that what y'all do?
Yes.
Easiest. Greater than or equal to, what did we say? 4. Okay. Oh, yep.
My bad.
Sure is. Good catch. Oh, I switched slides on accident. All right. I have that extra equal in there for some reason. There we go. All right, then on the other side of slide 5, quadratic functions will always have a variable squared in the equation and will create a parabola as its graph. The domain of the parabola will always be all real numbers. You see that? The domain will always be all real numbers. The range will always be greater than the minimum or less than the maximum, unless there are other constraints in the function. So since we have a minimum here, it's going to be greater than that minimum value. So the minimum is at -4, so it's greater than -4. Let's drag and drop the words for our definitions. So let's see. We have all of these we need to drag and drop. I'm going to copy them or drag them over here so I can find the spot for them. I'm going to zoom in. Okay, graphical definition. Point where the function crosses the y-axis or have an x value of 0. What is that called? Y-intercept. So in order to find that, you would evaluate the function when x equals 0. Since f of 0 equals c, the y-intercept is at 0c. So you plug in a 0 for your x. Next one, points where the function crosses the x-axis or have a y value of 0. X-intercept. Values of x that make f of x 0. Yep. So what is x when y is 0? And we are going to learn about the quadratic formula also. Vertical line through the center of the graph. Axis of symmetry, exactly. And we can actually find the axis of symmetry by using this formula. X equals negative b over 2a. So you probably don't know what a and b are yet, but I'll teach you that. The highest or lowest point on the graph of a quadratic function. Point. It has to be a point. Vertex, yeah. And then the y-coordinate of the vertex. That's your maximum or minimum. I guess we didn't need another parabola word here. Let's move on to slide 6. We have the function. So look at this. We have x squared, 2x, and negative 5. So this is a type of parabola that's been moved. Remember, our parent function is x squared. It's just the parabola, and it goes through the origin. Well, this one has been moved right and down. So x squared plus 2x minus 5. So if a is, I don't think we even have the standard form. So let's write the standard form. Y equals ax squared plus bx plus c. I'll zoom in. I'll make this bigger, actually. This is our standard form. Y equals ax squared plus bx plus c. If a is positive, so drag over positive. If the first value, the one with the x squared, is positive, the parabola will open upward. When a parabola opens up, it has a minimum. I guess upward. When a parabola opens upward, it has a minimum value. So it has a restriction. It doesn't go below this. Think of a parabola smiling and having a minimal amount of problems. So upward, minimum. So then the next one, see how we have a negative out front? That is what makes it go downward. So if A is negative, then the parabola opens downward. Drag these both over here. You feel so far away. You have to scroll back and forth. Do y'all have to scroll back and forth?
No.
Oh, it's just me?
Because yours is zoomed in so much.
Oh, gotcha. Okay. If A is negative, the parabola opens downward. When a parabola opens downward, it has a maximum. So it's like a hill. It has the highest point. Instead of having, we don't know what the lowest point is because these arrows continue to go on and on and on. Think of a parabola frowning and having a maximum amount of problems. So positive person thinks very little about their problems. Negative person thinks about the problems a lot. I don't know. I'm just trying to come up with something. All right. Anyway, let's look at our zeros, solutions, and x-intercepts. How many solutions does this graph have? Yeah, it just has one. So one solution is when the parabola touches or crosses the x-axis once. So then how many does this have? Two solutions. So when the parabola touches or crosses the x-axis twice. And then the last one's kind of floating in the air. So it has no solution. And it never touches. It does not touch the x-axis at all. So what are y'all thinking about this so far? Seems fairly easy. Knowing the vocab is probably number one on it. And once you know your vocab, it's easy to just point out different parts. I looked at the EOC problems on this, and mainly it is giving you a graph or giving you a function and asking you to identify these things. So let's look at slide 7. I want y'all to go ahead and work with your table group on this for the rest of the class period. And then we'll finish it up on Monday. So do as much as you can on this slide.